All right, sorry for the interruption. Let's continue with your elimination here. So, starting out with, remember, we need your like terms in both equations on top of each other. So when I have a y and then an x, that doesn't work. So you can rearrange this equation however you want to make in any order, x's on top of x's, y's on top of y's, constant on top of constant. So if you want to be a person who just always puts it in standard form, x plus y equals constant, x plus y equals constant, feel free to be that person. It doesn't matter. Or if you want to look at the equations and move things based on the equation, that's also possible. So I could move and put the x over and the y over on both sides. I can do that. Or I'm going to show you just for a different example, a different way of doing this so that you can see how this works. I'm going to keep my x on the left side and the y on the right side. So on this equation, I need to move both that 2y and that 7x to opposite sides. So I need to subtract the 2y and subtract the 7x so that it becomes negative 7x equals, now I do need to put the y first because that's how it is in this equation. So negative 2y plus 8. The important thing is paying attention to your signs to make sure that you have the correct positive or negative with it. Because it's positive currently, but I need to move it to the other side, it needs to turn negative. Same thing with your y, it's currently positive, so you need to make it negative when you move it to the other side. And then the 8 that was there didn't change, so it stays a plus 8. If you would have needed to move something that is a negative, it would switch to become a positive. Okay, so just keeping that in mind. Now, you can, however you want or need to, multiply one or both of these equations by some constant in order to create opposites for x's or for y's. Keeping in mind that they do need to be opposites, so one positive, one negative. And the number you multiply doesn't matter as long as your coefficients of x or the coefficients of y become opposites. So I can look here and I can see I have a negative 7 and a positive 14. So I can multiply negative 7 by positive 2 to get the opposite of 14. That can work. If you didn't notice that, I've said before, you can multiply this top one by 7 and the bottom one by 14. There are lots of numbers you could multiply by, and it's going to make it work out, okay? So as long as you create opposites. So I'm going to go with the route of I can multiply the bottom equation by 2. Why is it positive 2 this time and not negative 2 like the last time? Well, because I already have a negative in front of this x, and this one is positive. Before, I had 2 positives, and that was my issue. I need one of each. So distributing that 2 to both terms. So I'm going to rewrite this top equation. It's not going to change. Just so that I have it in a nice place. And then I'm going to distribute this 2 to become negative 14x equals 2 times negative 2 be negative 4y, and 2 times 8 is 16. All right. So now we are going to add your 2 equations together. 14 plus negative 14, that eliminates. However, you need to put a 0 there. You have to have an equation which has to have things on both sides of your equal sign. So if you eliminate and there's nothing left, you have to put a 0 there. Back over to here, I eliminated it, but there's still this y. So that's why I didn't need a 0 there. All right. When I continue to move on, I have 4y plus negative 4y, which is also 0. This is an instance where I don't need to put that 0 because I have something else here. So these also eliminate, and the negative 4 plus 16 would be 12. Okay, this is where we talked about infinite and no solutions. Okay. Down here. Had to find it, sorry. No solutions is if both variables eliminate, but not your constants. And infinite is if everything eliminates, variables and constants. So both of my variables eliminated, but my constants did not. This is a no solution situation. If you wanted to type these equations into your calculator in order to graph them to check, you should then see 2 parallel lines. They would never intersect. It would be infinite if instead of 0 equals 12, you had something like 0 equals 0. Everything is gone. All right? Okay. We are done with elimination. I do not need you to know both elimination and substitution. So if you were happy with elimination, you can stop right here start working on your lesson. Or if you didn't care for elimination, you can learn substitution. Or if you just want to know how to do both of them, and sometimes you do elimination, sometimes you do substitution. It doesn't matter to me, but you do not have to know how to do both. Substitution, let's do it. In substitution, you need to solve one equation for one variable. So you need to have an equation, one of your equations needs to either be y equals 7x minus 8 or x equals 3y plus 8. Doesn't matter which equation, and it doesn't matter which variable. There will, though, sometimes be a specific equation and a specific variable that's easier to solve for. Not always, but sometimes. And we'll see some examples. I'll show you some of those. The variable that you solve for equals an expression. If it says y equals 2x plus 9, then y and 2x plus 9 are equal. So you're going to substitute in the other equation that is not solved for that variable. You're going to take out the variable that you says equals, y equals, so take out y. And substitute, well, what does y equal? 2x plus 9. Substitute that in. When you do your substitution, if you've done it correctly, your new equation should have one variable. Probably twice, but one variable, x and x, or y and y. If you still have an x and a y, you've messed up. Try again. Because you have only one variable, you can now solve that equation. Once you have solved that equation, you know what x equals or you know what y equals, plug that in. Take the value that you found and substitute that into one of your equations. It doesn't matter, but there is going to sometimes be easier equations. It's going to be easier to plug it into the one that you have solved for that variable. Meaning you had y equals 2x plus 9. You have now found x equals 5. Plug x into 2x plus 9. As opposed to the other equation. But doesn't matter. Any equation, plug it in. Write your answer as your coordinate point. Feel free to check it by graphing on your calculator. Okay, we've talked about no solution and infinite solutions with graphing. No solution looks like parallel lines. You will know that by calculating if in step 4, when you're going to solve the first variable, when you solve, your variables cancel, and you're left with two unequal constants. 5 equals 9. No, 5 does not equal 9. No solution. However, it's infinite, which would mean graphing is the exact same line, is if you solve and your variables cancel, but now you're left with two equal constants. 5 equals 5. Oh, yes, it does. Infinite solutions. That is in step 4 when you are solving for the first variable. If you have an answer to x equals or y equals, if you get an answer here, you're going to have a coordinate point. So if when you're continuing to solve, when you solve for your other variable and you somehow get one of these that's trying to tell you infinite or no solutions, you have messed up somewhere. Infinite or no solutions should stop at number 4. So let's look at some examples. In your first equation here, you have 2y equals 3x plus 8 and 10y minus 15x equals 40. Pick any equation, and in that equation, pick a variable to solve for. I don't care if you want to always solve for y in the first equation. I don't care if you want to always solve for x in the second equation. Doesn't matter. Pick one, solve. But if you look at the first equation, y is already almost by itself. All I need to do is divide everything by 2. Everything by 2. That's going to get y by itself. So that's going to lead that to be y equals, this is going to be a fraction, 3 over 2x plus 8. And some of you are going to sit here and say, I don't want to have fractions. And yeah, it's great if you don't have to have fractions, but sometimes there's no way around it. I could try to solve this equation for x. I could try to solve this one for x or for y. I'm going to get a fraction, unfortunately, in this one. That's just how it is. But feel free, if you get a fraction, to try solving a different equation or a different variable. It doesn't work here. So we're going to move on with this. So y equals 3 over 2x plus 8. I'm going to use that in the other equation. Right here where I have a y, I'm going to plug in what y equals. So I'm going to keep this 10, parentheses, take out y, substitute in what is equal to y? 3 over 2x plus 8. and then leave the rest of the equation the same. Minus 15x equals 40. And then you're going to solve this equation. Now, this is where it's potentially harder. It's been maybe a while since you've done this. So you're going to start with distributing. So you're going to distribute this 10 to both terms. So 10 times 3 over 2 would be 15x plus 10 times 8 is 80 minus 15x equals 40. Next thing you're going to want to do is combine your like terms. So you have this 15x minus 15x. 15 minus 15 is 0, not x, because that's 1. It's 0. These those are gone. Leaves you with 80 equals 40. Okay, my variables have canceled. So, oh, hold on, pause, rewind, come back. Maybe you already caught it. This 8 is not supposed to be an 8. 8 divided by 2 is supposed to be a 4. So this is supposed to be a 4. So this should be a 40. So this should be a 40. So my bad. Come back up here. When I did my dividing, when I solved for y, 8 divided by 2, I forgot to do is 4. Maybe you already caught it. Cool, move on. But if not, this should be a 4. So this should be a 4. So 10 times 4 is 40. When I cancel now, I have 40 equals 40. Sorry about that. Okay, still, both of my variables have canceled. So now, are they unequal constants or equal constants? Does 40 equal 40? Yes. That leaves me with infinite solutions. Which you could check by graphing on your calculator if you want. It should be the same one. And the next example here, let it try to focus. There it goes. Once again, you need to solve one of your variables, one of your equations for one of your variables. It does not matter which equation, does not matter which variable. Whichever one you want. I'm going to notice in the first one, I have y minus 17. All I need to do is add 17 to the other side to make that y equals. That's what I'm going to do. You can feel free to solve a different variable or a different equation and try this problem. You should get the same answer as me. Now, the issue is if you don't, I can't in the video show you what you did wrong. You're going to, raise your hand, ask Mrs. Mullen. But I'm just pointing that out. There's more than one way to solve this using substitution. So this equation is going to become y equals negative 3x minus 8 plus 17. Now, you can, personal choice, lots of options here. Some people don't like this. They want to distribute that negative 3, and you absolutely 100% are allowed to do that. And then after you distribute, you're going to notice you have some like terms. You can feel free to combine them. It doesn't matter as long as you are algebraically doing correct math. Okay? So you can use this, or you can distribute the negative 3, or you can distribute the negative 3 and combine like terms. You do which one makes your heart happy. I'm going to leave it like this just to show you what to do, how you could go from here. So once again, I have a y equals. What does y equal? All of this big mess over here. So where my y equals, I need to plug that in. So 4 parentheses, all of that in there. Negative 3 parentheses, x minus 8 plus 17. Close that parentheses, the rest of the equation. Minus 5x equals 28. Notice that I just have x's now. That's like the whole point. If you had a y somewhere in there, you've messed up. Now, when we go to solve this, we need to distribute first if there's distributing, and there is distributing. Now, you should distribute from the inside out. So you're going to distribute this negative 3 here. So if you would have done that back up here, it saves you the step here. You're going to have to do it at some point. It doesn't matter when you do it. As long as once you substitute, that's the first thing you do. So I'm going to distribute this negative 3. So leave that 4. Still leave the parentheses on the outside. I haven't done anything with that. Negative 3 times x is negative 3x. And negative 3 times negative 8 is positive 24. Now those parentheses get to drop because I distributed the negative 3. Bring down your plus 17. Close your parentheses. And then everything else is the same so far. You have two options. You can distribute again, or you can combine the like terms inside the parentheses and then distribute. It doesn't matter. Either one. It doesn't matter. personal choice. So I'm gonna combine like terms first. So I'm gonna combine your 24 plus 17. So that becomes plus 41, still in parentheses. I did not distribute yet. Minus 5x equals 28. And now I'm going to distribute. You could distribute first. You make sure you distribute to all three terms and then combine like terms. Doesn't matter. If you do it in either order, you should end up with the same answer. Negative 12x plus 164 minus 5x equals 28. So if you would have distributed and then combined like terms, you should still end up with the same thing. Okay, now we're going to continue solving. I have distributed all of the distributing. I'm going to continue combining like terms. I combined some like terms up here. Now I have more like terms since I got rid of my parentheses. Negative 12 minus 5 would give me negative 17x plus 164 equals 28. Now I'm going to keep solving. I'm going to subtract this 164 on both sides. 28 minus 164 is negative 136. Then I'm going to divide by negative 17. And I'm going to get x equals 8. There is the first part of my coordinate point. I'm not done. Now I need to go find y. You are allowed to use the original top equation, the original bottom equation, or the equation you converted over here. Any of those three, feel free to pick them. But I'm going to lead you towards this one because y is already by itself. So y equals negative 3 in parentheses, 8 minus 8 plus 17. I'm going to lead you towards this. So this was the x. This goes here. I'm going to lead you towards this because now this whole thing, type it in your calculator. Exactly like that. Negative 3, 8 minus 8 plus 17. So y equals 17. Because you already had your variable by itself, you can just type it in your calculator. It will potentially make life easier. Now your answer is your coordinate point, 8, 17. Making sure you put x and then y. So if you had solved for y first, make sure it actually goes second in your coordinate point. You do not need to know how to do both substitution and elimination. You pick one. Pick your favorite. Get really good at it. You do need to know how to graph it on your calculator. You are allowed to, after you do elimination or substitution, graph it on your calculator to make sure that it's correct, but I need the work on your knowledge check. So get good at either substitution or elimination unless you want to do both, but you are not required at any point in time to be able to do both elimination and substitution.